Hello everyone, Assalamu alaikum. Welcome to the 8.2 continuous random variable. This is the two main objective, finding the probability density function, PDF, finding the cumulative distribution function, CDF. But for continuous random variable, we call it density now, okay? Not distribution. Probability distribution function is for discrete random variable, but now we are at 8.2, we call it density. Okay, probability density function of continuous random variable. Please highlight this word, density. Why does it call density? So this is the reason why. This is the definition. Please write it down. Please highlight this word, density, and the total probability for the density function is equals to 1. Always remember, back to the basic, total probability is always equal to 1. All right, but now we are learning density function. So density is involving a graph where this graph, we can find the area of the region from a limit to another limit, you know. So basically, a density means finding the area of the region from a limit to another limit. Okay, that's why in order to find this area of the region, or we call it area under the graph, we use an integration. Remember, 2.4, we have learned definite integrals where we have learned the area of the region. So in order to find the area of the region, we sketch the graph first, isn't it? And then we shade the region. After we shade the region, we find the area, A1 and A2, by using the knowledge of integration. Remember? Integration from a limit to another limit. So you have learned this before, and we will use that knowledge in this topic 8.2 continuous random variable. Okay, so that's why this is called density, probability density function. It means we will need to use the knowledge of integration. Even though this is probability, we use integration. And remember, the total probability density function is always equals to 1. Right, let's start with the example 5. A continuous random variable has PDF, density, yeah? You might want to highlight this word, density. So density, whenever you see the density word, it means you have to draw. You have to sketch the graph. So the graph here is fx, 1/4, 4 minus x. For the condition here, x is in between 1 until 3. This is the limit, you know that? This is a hint to you guys that we will do integration. But before we do the integration, we will need to sketch the graph. So here goes a tips lah. A tips for you guys in order to make a simple graph. Okay. Step 1, sketch the graph. In order to draw or sketch a simple graph, we use these tips. We just use the limit here. Okay. Use the limit here, which is number 1 and 3. So when x is equals to 1, the function f1 is equals to 3/4. Therefore, you will get a point already, 1, 3/4. So you can just sketch the x-axis and the y-axis first, and then you just label your point, which is the first point is 1 and 3/4. So you label it, put a densicle there. It is a densicle because of this, less than or equal. So less than or equal, it means densicle. So not to worry about that. And then you find another limit, which is 3, and then you will get 1/4, which is here, another point. And then after you get the 2 point, you just make a line. How do you know this line is going downwards? Here goes the function. The function here say negative x, guys. Negative x means negative linear. So negative linear, the basic shape is going downwards, right? And then you already know that this is the limit from 1 until 3, so you put a dotted line there, and then you can shade the region. So this is what we learned from the 2.4. All right, and then here goes the next step. So the next step is finding the integration then. Finding the integration from the limit x of 1, the limit x equals to 1, until the limit of x equals to 3, right? So we want to find the area under the graph. So we have to integrate it, okay? We integrate it. So when we integrate it, we put an f first. Here goes the f, okay? I just want to show you step by step. I put the f first, the function f here. So now I put in the 1 over 4 times 4 minus x here. So 1 over 4 times 4 minus x. Don't forget your dx. And don't forget your limit 1 until 3. Okay, don't forget that. The thing is, we do not need to put the area equal. No, we do not need to put area A equal, because this is not chapter of the area. This is the chapter of probability density function. It is enough to write down the integral. Okay, enough. So now, read the question. Verify that it satisfies the condition of probability density function. What is the condition, guys, of PDF? The condition of PDF is just this part. The total probability must be equal to 1. So let's see whether this integration will lead us into 1 or not. Let's integrate it and we will find it out. Okay, and so what should we do? We need to integrate it. So I bring 1 over 4 outside, and then I start to integrate. Integrate 4 will get 4x minus integrate x will give me x squared over 2. Close bracket, and then don't forget to put your limit 1 until 3. And then sub in the limit into the x here. And here we go. I solved it and I got 1. As a conclusion, final step, step 3. Since the integration of the function dx, with respect to x, from the limit 1 until 3 is equals to 1, okay? The total probability is equals to 1. Since we have proven it, it is equals to 1, thus, therefore, fx is the probability density function. Put a word shown there, showing that you have managed to prove the total probability is equals to 1. Or maybe you should write there verified. Verified. We have verified that it is total probability equal to 1. Perfect. Now we got to solve the second question. Find the probability of x less than 2. Oh, what does this mean? Probability x less than 2. So I think you might want to have a look at this part first. This is the characteristic of PDF, okay? So the characteristic of PDF, instead of just write it down in terms of integration, we can also write it down in terms of P. P means probability, okay? Just that finding the probability of x in between the limit here. These are the two limits. So make sure you get to know the limit very, very well in order to be good in this subtopic 8.2, continuous random variable. So whenever you know this is from A to B, you can also write it down as probability P in a bracket, x is in between two of this limit. Okay, so now we understand that this is finding the probability of x less than 2. So x less than 2, where is 2? 2 is here in the middle there. So you might want to put a dotted line there. They said they want less than 2, so it means this is the place that they want to find. This is the region that they want to find. This is the only part that they want to find, which is less than 2. Therefore, you can start the limit from 1. Okay, and the limit from 1 until 2. This is the only region that you want. Therefore, you know that the limit is from 1 to 2 only. And so you can write down the limit, which is x equals to 1 until x is equals to 2. That's it. Okay, you cannot take more than 2. You must take 2 as the upper limit, because they said here probability should be less than 2. Okay, even though this is less than, not equal, but then still the upper limit is 2. So now we insert the function, which is 1/4 times 4 minus x dx. And so our job is to find what is the probability then. So 1/4 times 4x minus x squared over 2, and then put a limit from 1 until 2, and then our job is to sum in. You must show your working. 4 times 2, show the working, and then 2 squared over 2, and then minus with what? 4 minus half. Okay, 4 minus half. Don't forget to put a bracket, a proper bracket there, and you will get your answer, which is 5 out of 8. That is the total probability for this function. That's it. Good luck.